So basically, ladies and gentlemen, our objective for today is to discuss some of the heavy hitters and sort of the evolution of the theory of an atom. The evolution of the theory of an atom, and then talk about the structure of the atom. So we're going to go over some scientists that had, and some philosophers, okay, not necessarily renowned for their science work, but let's talk a little bit about the history, okay? The history of the atom. 1460, a man named Democritus developed the idea of an atom. How'd he do this? He took a mortar and a pestle, which is just something I think we use this a little bit in the lab, but it's when you have chunks of something. I used it the other day to mix up our mixture that we used in the lab. When you have chunks of something, for instance, I had chunks of coal, big chunks of coal. I had to get those smaller, so I took out a mortar and pestle and smashed that chunk into smaller particles. That's similar to what Democritus did. He crushed up materials into smaller particles, and he called those particles atomos, which is the Greek word for indivisible. Then came Aristotle. Aristotle said that everything was made up, everything consisted of 4 different elements. And the elements were fire, water, earth, and air. Fire, water, earth, and air were Aristotle's 4 elements. John Dalton, okay? John Dalton came up with what he called the solid sphere model. So Dalton came up, he looked at Democritus' idea of the atomos, and he said, well, the atom, what it is it's just a tiny little elastic sphere, okay? A little elastic sphere, and he took that O out of it, of atomos, and said these are just atoms. Now we're getting into, Dalton. It's important. These things are important to know and what they're playing with, what they're dealing with, okay? J.J. Thomson, Joseph John Thomson, had what we call the plum pudding model. The plum pudding model. What happened? Okay. What happened is he had an experiment with a cathode ray tube. He found that atoms sometimes ejected a small negative particle that he named the electron. He named the electron. Okay. The plum pudding model came about because he said that the electrons were scattered around positive charges. Okay, they were scattered around positive charges like the plums that were surrounded in pudding. Now, I myself have no idea what plum pudding is. I've never seen plum pudding, nor have I ate plum pudding, but to me, it kind of reminds me of tapioca pudding. Have you ever had tapioca pudding where they've got the little spheres inside the pudding? That's more to me what it was like. These little spheres right here, Thomson said were electrons. In this whole purple area here was positive charges, and that the positive charges balanced out the negative charges. So we credit J.J. Thomson with the whole idea of the discovery of the electron. Ernest Rutherford, 1910. Okay? We credit Rutherford with discovering the nucleus. He did an experiment that we just simply call the gold foil experiment. The gold foil experiment. What he did is he fired helium nuclei, okay, at this piece of gold foil. The gold foil was a very, very, very thin gold foil. It says it's only a few atoms thick. But what he found was that these helium nuclei would bounce off and deflect off of the gold foil. So he said that there was something, some dense material that was causing that helium nuclei to reflect or to bounce off of the foil. Sometimes it passed directly through, other times it ricocheted slightly, sometimes it bounced straight back at the emitter. So he said there was something dense in that gold foil that was causing those nuclei to deflect, and he said that was what he called the nuclei, the nucleus. So he said the nucleus was positively charged and that it held the electrons together because they were negatively charged. Building on that was a gentleman named Niels Bohr. Niels Bohr came up with what we call the planetary model. Bohr said that, yes, we have this nucleus, but the electrons are orbiting the nucleus much like the planets are orbiting the Earth. That's why we called it, or excuse me, planets are orbiting the sun. Okay? That's why he called it the planetary method. You can see that Bohr, was studying under Rutherford at the time. Okay? He was working with Rutherford at that time. The electrons had orbits. So if you see those electrons spinning around the nucleus, that is exactly what Bohr thought on his model of the atom. Now we're going to add some things in here. Okay, we're going to add some things in here, but if you look at this atom right here, okay, if you look at this atom right here, it has 2 protons. Okay, 2 protons. Well, this is a helium atom because helium has the atomic number of 2, meaning that there are 2 protons. If it is a balanced atom, there's also 2 electrons. And in this case, with helium, there are 2 neutrons. Okay? So protons, neutrons, electrons, and then this little red thing was the electron shell, the orbital that Bohr said that those electrons went around the nucleus. Now, we're going to add some new people here, folks, that were not on the video. So you might want to make a note of these people and what they were responsible for. Not all of this material is important. Not all of this material is important, but you should know what they're credited with. Okay? Robert Millikan, 1908. Okay? He proved that the electrons were negatively charged. He proved that the electrons were negatively charged. Erwin Schrödinger. Schrödinger said that the atom consisted of a dense nucleus and many protons and neutrons. He said that they were surrounded by electrons that were on these what they call electron clouds. He said that these electron clouds all had different energy levels. The electron clouds had different energy levels, and he said that the protons and the electrons had different charges. Chadwick discovered the neutron. He found this out when he was looking at alpha waves. He bounced them off the nucleus. And he said they were bouncing off something that they were calling a neutron that had no charge. It was neutral. Now let's talk a little bit about this helium atom. You're going to see them written out like this, okay? Where you see the symbol of the element, which is He for helium. You'll see this 4, and then below it you see a 2. Okay? What do those things actually mean? Well, that 2 is the atomic number, which is the number of protons. The atomic number, the number of protons. Each element has its own number of protons. If you look up at your periodic table, oxygen has an atomic number of 8. So that means that oxygen has 8 protons. If you look at iron, iron has an atomic number of 26. So iron has 26 protons. Up at the top, the 4 is the atomic mass. The atomic mass is equal to the number of protons and the number of neutrons. So if helium has an atomic mass of 4, and we know that helium has 2 protons, 4 minus 2 is 2, so helium must have 2 neutrons. So the atomic mass minus the atomic number will yield to you the number of neutrons. If we have an electronically neutral atom, if the atom is neutral, the number of protons are equal to the number of electrons. Okay? Protons equal electrons if the atom is neutral. What you're going to see later on is that these atoms form what we call ions. Okay, they form ions, meaning that they have either gained or lost electrons. Gained or lost electrons to form ions. But if it is neutral, the number of protons is equal to the number of electrons. So if this is a neutral atom of helium, it has 2 protons and 2 electrons. Electrons are arranged in what we call energy levels. Okay? These energy levels are around the nucleus. The first energy level, the first electron shell, can hold 2 electrons. The second electron shell can hold 8. The third electron shell can also hold 8. And you will go on, and we'll understand these electron shells better when we talk about the electron configurations next week. Okay, we'll talk about electron configurations next week and start drawing those out. You will understand those better. Okay, but these different energy levels, which are also called shells, are located around the nucleus. They are the so-called orbits of the electrons. Now, if we look here, proton, neutron, electron. Obviously, we know that the charge of the proton is positive. Okay? Its mass is 1. The charge of the neutron is neutral. It has no charge. Its mass is 1. Charge of electron is negative, and its mass is nil. What I mean by that is on the mass of an atom, okay, the mass of the atom, the electron is so very small when it's compared to the proton and the neutron that it offers nothing towards the mass. Okay? That's not totally true. It offers something, but it's so very small that we consider the mass of the atom to come from the proton and the neutron. Okay? So the mass of the atom comes from the proton and the neutron. So very little comes from the electron. Last thing on the video we talked about were isotopes. Isotopes. And what an isotope is that there are 2 or more forms of the same element that differ in the number of neutrons. Okay? Differ in the number of neutrons. Remember we said that each element had its own amount of protons. So, we talked about hydrogen in the video. Okay? Hydrogen has 1 proton. Okay? However, we have 3 different isotopes for hydrogen. Okay? And it varied based on the number of neutrons. So if we look, okay, if we look at hydrogen 1, hydrogen 2, hydrogen 3, and this is just an interesting side note here, that you'll see things written like this. Probably one of the more common ones you've heard of. Have you ever heard of carbon-14 as opposed to carbon-12? 2 different isotopes. But here, the hyphen method, hydrogen 1, hydrogen 2, hydrogen 3. What that is just simply telling you is hydrogen 1, okay, hydrogen 1 has 1 proton. 1 over 1. Remember, this is the atomic mass, this is the atomic number. So if it's hydrogen 1, it has 1 proton. How many neutrons? 0. Hydrogen 2, deuterium here. That 2 is the atomic mass. meaning that it has one proton in the nucleus, one neutron in the nucleus. Hydrogen 3, okay? Tritium has one proton and it has two neutrons. So the mass is 1, 2, 3. That's where the 3 comes from. So these are 3 different isotopes of hydrogen. Remember, what is changing is the number of neutrons. If we change the number of protons, we have a different element. Because if it has 2 protons, it's helium. So we can't change the number of protons in the isotopes. It's always the number of neutrons. So let's look right here. Here is boron 10. Here is boron 11. If you look on your periodic table, boron has an atomic number of 5. So that tells me boron has 5 protons. What's 10 minus 5? 5. So that tells me that boron 10 has 5 neutrons. If I look at boron 11, what's 11 minus 5? 6. So that tells me on boron 11 that it has 6 neutrons. So the difference between boron 10 and boron 11 is that it has added 1 neutron, and they are what we call isotopes of boron.